Hello friends, today we are going to learn two very important blocks called as NormX and ScaleX. Now why we want to study these two blocks? Many times the situation arises that we want to scale the analog input. For example, we have a temperature range of 0 to 200, minus 30 to 50, minus 10 to 100, or whatever is the range of the temperature in degrees Celsius need to be read into the PLC. As you all know, that analog input is having the data stored in counts form, that is it starts from 0 to 27648. So if I want to read a data of say 0 to 100 degrees Celsius in PLC, when 100 degrees Celsius arises, my analog input will read 27648, that are the maximum counts. If I scale it to that, if I don't want to scale it to 100, it is 100 if 100 temperature shoots up, it should 27640. I want something else, like I want half the counts, that is 13,000 something. So I can even do that. But how to do that? I need to tell the my PLC using some logic. Now for that purpose, we are using two blocks, that is NormX and ScaleX. Let's go and do the actual practical exercise of this. So go in basic instructions and open conversion operations. Before scale x, you need to normal x, that is you need to normalize the output, that is the value of the tag at the value input, by mapping this to a linear scale between 0 and 1. How to do that? Let's see. Now we have 0 to 10 volts analog input available with us. So I will just write it here. But before that, I should ensure whether my analog output is available or not. Going to device configuration. So we have a onboard analog input. So just click on this and check this AI. What is the address? It is IW64 and it is 0 to 10. IW66 is 0 to 10. Now this can suffice our problem. We will go into menu B and write IW64. Go here and say it is integer. Then the red marks goes. Now as we know, it is going to provide me the values in the range of 0 to 27648. So it is 0, it is maximum is the maximum counts are 27648. For SL1200 PLC, I want the output in real form. So I will just click on real. Okay, so the real output is available here. I will write address as MD60. This is random value. You can check any value. Only thing is should not be used in your program. Go and rename the tag as normalized output. Name it as normalized output. So now this is normalized. After that, the block called as calyx has to be used. So this normalized output will act as input here. So here I want to add realize the output. My minimum temperature is 0 and maximum temperature is 100 degrees Celsius, and my output I want to store it in MD64. Which I will rename it as scaled analog input, which can be used in my program for my other computations. Like I want to compare it with some value, I can use this. This was all about analog input, normalization and scaling. Now let's do analog output for scaling. For the same, we need to configure analog output in our PLC. As the CPU 1214 CDC doesn't have analog in the output on the on port, we need to add the analog output separately. Okay, I have taken two analog output modules. You can take four as well. There is no significance whether to take two or four. As per your requirement, you can select. Go into a queue. Check the address QW96. Okay, now the procedure is I have counts in no, I have the value and I want to change that value to the counts value. So the same procedure, only thing is we need to revert the ranges. Okay, how to do that? Let's begin. Same blocks to be used again. I have 100 here. Now I will write here as computer temperature, or I want to control speed of motor, so I can set the set speed here. Rename is at computed set speed. Or you can say it as normalized set speed. Again use a scaling block. And here I want to scale this to minimum as 0 and maximum as 27648. So this is a scaled set speed and it is returned to the analog output of our PLC. So this PLC, I can use this value and write it to my analog output. For example, here in our PLC it was QW96. Let's verify again. So first one QW96. I can click on this and change the address. Click on rewire and rename it as this one. QW96, and this is my actual output, analog output, which I can directly connect to the input of my drive, which is having 0 to 10 volt as the reference to control the speed of my motor. Just save and download. You will have the same procedure to be done using either adder subtractor block. It's same as y is equal to mx plus c. Okay, so if its scale is ranging from, as we know that analog input is having counts, it is 0 to 2 cents space sort of rate. So if my current is 0 to 20 milliampere, how will the output change? It is when there is 20 milliamperes, I will get 276 for it. When it is 0 milliampere, I will get 0 counts. In between, I can get 13,000 counts. That means the output will be, or the input will be 12 milliamperes. Now to use the same in my PLC, I need to scale it. So how to scale to the real values? So these are the real values. This is the normalized output, that is 0 to 1. Vice versa for my analog output. Now analog output has to drive something. For example, I want to configure the output, analog output of my PLC to control the speed of my AC motor. And the AC motor, the drive is having control of voltage. That is, if 0 to 10 volts is given to my motor, the motor will run at a maximum speed. If 5 volts is given, it will be reduced to 5 volt, that is the 50% speed. Now for that procedure, we have, for example, 0 to 100 rpm is my set speed, that is maximum speed is 100 rpm. I want to scale normalize it. I will normalize it, and by normalizing I will write this to my analog output by scaling it to 0 to 276 for it. If the 500 value or the 50 value of the set speed is there, the counts will be given as 13,000. If 100 value is given as a set speed, the full maximum reference will be written to the analog output, and the analog output same will be applied as to the analog input of my drive. This is all about of using and configuring the analog input, analog output, scaling and normalization blocks. So thanks for watching.